just sitting there anyway, it can be part of the grid that 95% of the time when it's sitting unused. Then there's the low carbon fuels, and there's way too much to talk about here. As I said, this is also my area of research, and I could go on at length in reporting. I'm not going to certainly talk about all kinds of low carbon fuels, but I'm going to just show you what I have done, and those of us who do research in this area have realized is we've categorized the different kinds of low-carbon fuel technologies essentially into four categories. There are purely chemical platforms. Existing biodiesel is essentially that. Thermochemical platforms uses heat and catalysts uses heat and catalyst technology. Biomass processing technologies take wood, fiber, other kinds of materials and break them apart. And then finally, sugar conversion technologies. This is where ethanol comes in. It's just fermentation. You're essentially using a microbe to convert sugars into some other usable energy form. I'm not going to talk about all these, but I do want to point out two. One is something called aqueous phase reforming. And this is one of these sort of breakthrough technologies that shows a lot of promise. It's actually a company in Madison, Wisconsin called Virent Energy Technologies. They can take any soluble sugar source and using a catalyst, they make something that is indistinguishable from existing gasoline. So they're taking sugars and they call it biogasoline. Here it is here. In fact, it looks yellowish like gasoline. This is actually water that's left over from the process. Their primary problem right now is to find a source of sugars that doesn't compete with food. In fact, for demonstration purposes, they've essentially defined sugars. Sugar, it works really well. We've actually sent them some sugars we've created here at UWSP from paper mill waste. And they are interested in our process for essentially taking waste from mills and turning that into sugars. Okay? And this works. I mean, in fact, it turns out the biogasoline they make doesn't have the low energy density problems that ethanol has. In fact, it's got slightly higher energy density than existing gasoline. In fact, these guys got interested. This is the Ferrari Formula One team who has been running on biogasoline from Virent. Partially because of interest in sustainability, believe it or not, but partially because they feel it gives them an advantage because they get more energy per volume, per weight of fuel. Since I already talked about carbon fiber and monocoque construction and lightweight materials, all of those have really been developed from this field as well. Then the last thing is, I've talked about cars. What about aviation? Boeing, maybe you've heard about this. This is a new plane from Boeing, which actually goes part of the way to some of these solutions. The 787 is the new plane from Boeing. It has about 50% lightweight carbon fiber production. It's substantially lighter, and they developed some new engine technologies that actually make it quieter and lower emissions than existing engines. It basically increases the fuel efficiency by about 20% over existing fleet of airplanes. But when you talk about creating a fuel or a source of energy for aviation, there are a number of requirements, a number of problems that have to be overcome. One is the energy density of the fuel. Jet fuels carries substantially more energy per unit of weight even than gasoline. And essentially, there is no battery technology that's going to replace that. So you're looking at you're looking at some kind of liquid fuel. The other problem is, well, airplanes are awfully expensive. And so in order to use the existing fleet of airplanes, the aviation industry, the airline industry, is interested in drop-in replacements, things that can be used in existing machinery without replacing it all. And then finally, there's a lot of specific performance characteristics. In particular is something called cloud point. Diesel, if you guys are familiar with diesel and biodiesel, has anyone used biodiesel in the winter around here? Biodiesel and diesel fuel in general tends to gel, so it doesn't flow. It's really a bad thing when you're at 40,000 feet to have the fuel gel. And one way that's measured is cloud point. So you need something that's got a lower cloud point. It turns out chemically, one thing that gives it a better performance is a certain amount of aromatics, which are generally speaking only found in petroleum fuels right now. So in order to, the aviation industry, in order to get the performance they're looking at to make it safe and effective, there's a number of things that limit the number of the amount of low carbon fuels you can use. However, there are a couple of technologies that have come online. The most popular now are sometimes called hydrotreated vegetable oils. They're essentially biodiesel, but it goes through a catalytic and hydrogenation process. And these have been demonstrated. I know Virgin Airlines, British Airways, and others have actually demonstrated using bio-based biofuels for aviation. At best, they're finding you can blend them with about 50-50 blend with aviation fuel. The second technology that's coming on are what are called biojet fuels from alcohols. You can produce ethanol or butanol, another biological alcohol. Then using a series of catalysts, you can, what they call, upgrade it to make a jet type of fuel. Right now, it's something that works nicely in the laboratory, but doesn't work in the real world. So what is really needed is technology to make pure hydrocarbons and close the carbon cycle. And that's actually, and that's actually where I'm kind of leaving off right now. Oh, I see. It's possible to produce biojet fuel from the process from Byron's process as well. But I'm going to leave by promoting my own work. I see what's going on here. I'm going to go all the way through those. Here's the proposal that I submitted for pulp mills around here. The technology that we're developing here, and as I said, we've worked with Byron Energy Systems on, addresses a number of these problems. Number one, we're able to take, we're able to take biomass crops, woody crops, separate them into their component parts. I don't know what's happening to my slides here. Separated them into their component parts, which are lignin, cellulose, and hemicellulose. And by a combination of a process from Byron and one that we've invented, you can produce both green gasoline and biojet fuel. The lignin fraction you can actually process and produce bioplastics, in fact the carbon fibers necessary for making the lighter vehicles of the future as well. So we see that there's some opportunities here. As I said at the beginning, I don't want to talk in, I haven't covered every possible kind of technology, and you guys may have your own favorites. But a combination of electrification, better battery technologies and smart grid technologies, making lighter fuels or lighter vehicles for more fuel efficiency or battery efficiency, and creating some way to produce low carbon fuels, low carbon intensity fuels. These are the sort of main areas of research people are looking into addressing some of these problems in the future. This is something I've sent to some of the people involved with some of the pulp mills around here. I haven't had any direct contact yet, but this is something I would like to see become a reality in our region. So, thanks a lot.